Good morning, Miss Liu. I'm Shobhan Rao, son of Iswa Rao from DKA1C. Today, I'm gonna present to you about trigonometry with Mateshwaran, son of Subramaniam, Frazin Nazlin binti Faisal, and Nuraisha Yasmin binti Batrulisham. Okay, let's start. What is trigonometry? Trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. The field emerged in the Hellenistic world during the 3rd century before Christ, from applications of geometry to astronomical studies. The Greeks focused on the calculation of chords, while mathematicians in India created the earliest known tables of values for trigonometric ratios, also called trigonometric functions such as sine. Okay. Is Hipparchus. The first known table of chords was produced by the Greek mathematician Hipparchus in about 140 before Christ. Although these tables have not survived, it is claimed that 12 books of tables of chords were written by Hipparchus. This makes Hipparchus the founder of trigonometry. Trigonometry in construction. One of the construction that involves trigonometry is stairs. Stairs are a set of steps leading from one floor of a building to another, typically inside the building. Stairs are the most important components in a building. They are used to access various floors. There are different types of stairs such as spiral stairs, dog-legged stairs, open naval stairs, and etc. Stairs are used in commercial, residential buildings and also industrial buildings. It was in Mesopotamia and Egypt that the earliest straight single flight of stairs appeared, built to provide access to upper floors. Later, during the period of classical antiquity, Greco-Roman complex staircases started being built. Spiral, zigzag, and double riser staircase came into being. Okay, after this, I would like Mateshwaran to proceed the presentation. Thank you.
Yeah, thank you, Shobhan Rao. I'm Matishan Subramaniam, presenter number 2. My metric card number is 01DK821F1076. First of all, I would like to thank Puan Liu, who gave us this presentation about trigonometry. And secondly, I would like to thank my teammates who collected all ideas and points which we can share among us to get the correct ideas and points to present about the trigonometric construction. Okay, as told by Shobhan Rao, we are gonna talk about staircase. So in our presentation, we are gonna see what are the functions of trigonometric in building construction of staircase. Okay, before start to talk about functions of trigonometric in staircase construction, I would like to explain about staircase types. There are 6 types of staircase. The first one is the spiral staircase, which you are looking at now. The spiral staircase used in double-story house, home or office building. Okay, now look at the second picture. You can look at the helical staircase. This helical staircase will be at showrooms, which you can see at the showroom shops, and it's made for attraction of a design. It is made in a attraction of design because you can look at its design. It's mostly attracts the customers attractions to make a way on it. Okay, on third we can look at the straight staircase. This staircase is usually used in homes, connects to 2 levels or more than it, 2 levels or a floor to climb up. Okay, now look at the L-shaped staircase, which is staircase number 4. Okay, these staircases are known as turning stairs, which we used in working places. Okay, look at the fixed picture. U-shaped staircase. This is used in home, especially in home. This is very important to ensure the safety of kids, because if you look at the picture there, they got a border of border of making the kids safety without falling down the middle of the staircase every turning of the staircase. And finally, you can look at the window stairs. Okay, these window stairs are known as a kitted stairs used in mall or a hotel exit pathway. So this stair is usually used for in hotel exit pathway to make sure if any emergency they can get down easily and faster. So these are the types of staircase. Okay, yeah. Now we're going to look at the trigonometry in constructions. The function of trigonometry in construction of a building is a huge part. So, most of the constructions and buildings nowadays are constructed by the help of trigonometric. So now let's look at the function of trigonometry. Trigonometry is what helps the architects to calculate roof slopes, ground surfaces, light angles, structural loads, and height and width of structures to design a mathematical draft that a constructor can use for construction purpose. So, trigonometry are used to identify the ground surfaces, light angles, structural loads, and height and width of a structures to make the work easier for an architect and a civil engineer to construct it. Okay, yeah, now we're going to look at the trigonometry used in a construction of a staircase. So, trigonometry used in a construction of staircase is to identify the angle, height, width of a staircase. It is because by that we could construct a perfect angle staircase with the perfect height and width for each floor. It is necessary to make sure that the staircase is suitable for the construction or the structure of the building which we gonna build, so that the upcoming staircase would be the same as the first one, so that there would be one a collapse of design and collapse in building construction because of the staircase. So that trigonometry is mainly important to construct a staircase for measure the angle, height and width of a staircase. For an example, you can look at the picture in the slide. Okay, this picture shows that the width x and the height is 3 feet and the angle is 30 degree, which is suitable for a staircase built on the first floor. So this is how the trigonometry used to make a staircase and build a staircase in a building constructions. Okay, so now we're gonna look into more detailedly about a sum which is about trigonometric in a construction. So you can look at the slide. So you may looking at a picture in it. Okay, above that we are looking at explanation over there. So I would like to explain about the words over there. Okay, let's look into it. A square is equal to b square plus c square. Okay, the square of the length of the hypotenuse, which is a. So the a square is represents as a hypotenuse a, equals the squares of the lengths of opposite sides of a right angle triangle, which is b and c. So they stated that a is a hypotenuse a square and b and c are the opposite side of right angle triangle b and c. Okay, and the second picture over there is a solution of the sum. So let's look into it. There are three sides over there, A, B and C, and we are given a 90 degree on a right angle triangle. Okay, as basically we know that right angle triangle is basically have a 90 degree in it. Okay, so how do we identify the hypotenuse in every triangle? Okay, to make it easier, the easiest way to identify the hypotenuse is the longest side is the hypotenuse, as usually called hypotenuse is the longest side. So to easily identify a hypotenuse, the longest side is the hypotenuse. Okay, now look at the picture over there. In the picture, the longest side is A, so it must have to be the hypotenuse. So I stated that A is hypotenuse, B is opposite sides and C is opposite side. And beside the A hypotenuse, I got stated that longest side, so which is means hypotenuse. Okay, now look at it. To find out hypotenuse, how to find the length of hypotenuse? There's a formula to find the length of hypotenuse and the opposite sides over there. So I got stated the how to find the hypotenuse side of formula first, and some calculation over there about hypotenuse. Okay, formula is a square is equal to b square plus c square. So let's say I'll give a value for B and C. The length of B is 6 and the length of C is 8. So let's get into that. Okay, we're gonna apply the formula first. The formula is A square is equal to B square plus C, C square. Okay, and then we're gonna get into the value in it. Okay, let's put the value in it. So A square is, we don't know. A square we're gonna identify. So 6 square is equal to 36 plus 8 square is 64. So if you total up it, you'll get 36 plus 64 is equal to 100. Okay, on the our left hand side there's a square. So A square, so we got A square, we cannot complete the question over here, so we should have to move the square on the right hand side. If we move the square to the right hand side, we will change the square into a square root. It's a basic mathematical rules, mathematic rules lah. And if you look at the solution which I wrote over there, I've changed the square into square root. So I bring the square on the right hand side, so I'll give the 100 a square root. So if I give the 100 a square root, so it changed into 10. So which means square root of 100 is equal to 10. So the a value is 10. So this is how we're gonna find, this is how the method to find the side of a hypotenuse, the longest side. You just explain about how to find the hypotenuse. If you ask me that, hey, you just explain me about how to find the hypotenuse, how to find the B and C. So I could state it over there. Okay, to find the opposite sides, which is B and C, which is equal to the same formula only, just we're gonna change the sign, which is plus sign into the minus sign. Okay, so if you want to find the value of B side, means you can use B square is equal to A square minus C square. So this is the formula for identify the value of B. And for C is equal, is would be C square is equal to A square minus B square. So this would be your answer to identify the side of B and C. And that's all from me, and I would like to call upon the next presenter, Aisha Yasmin. All the best, the next presenter.
My name is Nur Aisha Yasmin binti Badrul Hisham. My number matric is 01DKA21F1142. Now, I want to present about bridge introduction of bridge. Bridge is a construction made to carry road traffic or other moving load to pass through obstacle or other construction. The required roads may be for pedestrians, road, railways, canal, pipelines. Obstacle can be river, valley, sea channel, and other constructions such as the bridge itself. Building railroads or road bridge are important structure in a modern highway and rail transportation system and generally serve as lifelines in society. Infrastructure system, bridge components, superstructure, bearing substructures, bridge classification, example by building materials, span length, span type, depth, location, use geometric shape and structure shape, and bridge time selection are discussed in this chapter. Moreover, the bridge has one basic purpose, which is to connect two points that are otherwise disconnected and difficult to access. It usually gives the shortest distance between 2 points and art of design and construction. This structure is highly dependent on mathematics and consequently the physics of stress and load. Some common factors that influence the design and type of structure include use and purpose, available building material, environmental conditions, cost, sufficient manpower, span length, type of riverbank, current, and project traffic loads. Independent head under the bridge, aesthetic and technological consideration are available. This is 7 of bridge. First is arch bridge. 2 is tight arch bridge. 3 third suspension bridge, 4 beam bridge, 5 cable bridge, 6 cantilever bridge, 7 truss bridge.
Hi, my name is Fazrina Zlin binti Faisal and my metric number is 01 DKA2 1F1 095 and selamat sejahtera to Mrs. Liu. And straight to my topic is trigonometry in bridge construction. Trigonometry is the science of measuring triangles, and engineers may use plain trigonometry to determine the size of an irregularly shaped parcel of land. It may also be used to determine the height of an object based solely on the distance to the object and the angle up or down from the observer. Bridges in particular are associated with triangles and trigonometry. Looking at many historic and some modern bridges, you will see many repeating and nested triangles. Triangles evenly distribute weight from any direction when applied correctly. Using trigonometry to solve bridge-related problems, you can determine how much force will be applied to the joints between the triangles and in which direction. In conclusion, we realize that trigonometry can be used in many areas such as astronomy and architecture. They can aid in calculating many things. They can also be used in car, desks, and benches. Without really climbing a tree, you can find the height easily with trigonometry. They can be so widely used in real-life applications and is very useful for most architects, astronomers, and engineers. We can conclude that without trigonometry, life would be much more difficult, and without going through the troubles, you can easily find something, so we think that it was a good invention by Archimedes, and thanks to this, many architects need not go through the trouble to calculate things, so it really helps in real life applications.